Welcome to the ATS Product, Tech, Science, and UX podcast. In each episode, we sit down with leaders across ATS to learn more about them and their roles within Amazon. From the ATS brand team, here's today's episode.
Hello, everyone. Welcome to this week's episode of the ATS Podcast. My name is Scott Mason. I'm a principal research scientist within the Air Science and Tech team, and I'm your host for today. I'm really looking forward to interviewing Tim Jacobs, who's the Director of Research Science for ATS Tech. Welcome, Tim.
Thanks for having me, Scott.
My pleasure. So let's get started. Just to start out, can you give us an idea what your career path has looked like to date?
Sure. Well, I started out as studying engineering, and I was at Purdue, and then went into graduate work and moved into an area called Operations Research and Engineering Systems. So after graduating with my doctorate, I actually started as an academician, but was shortly after that recruited to industry, specifically to Sabre and the airline industry. So that's how I got my start, and then worked for a number of interesting projects and so forth. And then actually ended up being recruited 6 years ago to Amazon. At Amazon, I was brought in to actually help start a research science organization focused on air and setting up an air cargo service along with the network that would need to actually be used to actually transport cargo packages for customers. But that focus area kind of grew into all different aspects of Amazon transportation services, including surface transportation, ground network routing, and so forth, as well as maritime and rail, what we call intermodal transportation. And that's where we are today. When I first started, we had 3 aircraft that were what we call wet leased aircraft, and that was in 2016. Today, we have more than 100 aircraft on 3 different continents. We fly a little more than 300 flights per day. So in a nutshell, that's how I got here.
Amazing. I mean, not many people get that kind of opportunity to sort of build something from the ground up, and to scale it and grow it into what we have today. That's just fascinating. Hey, Tim, I read somewhere that Amazon won the Informs Prize. Did that involve your team?
Yes, it did. In fact, we showcased, for that award, we showcased 3 areas, which included work from the Air Science and Tech team. It included work from the Marketplace Science organization under me. And it also included work from the Surface Research Science group. And then the first one, it showcased a number of the optimization models that we use to build the air network and operate the air network. And the second one, we showcased the Marketplace Science work included like the dynamic and the automated pricing work. And then in the Surface Research Science area, we talked a lot about the routing and the cost savings associated with efficient routing.
I would imagine, super proud of that. But do you have maybe some other highlights from your career journey you want to bring out for us?
Sure. Happy to. Some years ago, what really got me interested in optimization was basically the mathematics behind optimizing a problem, having an objective and a set of constraints to try to find the best possible solution. So as part of my dissertation, I did a lot of this kind of work. And one of the early highlights for me was winning the Collingwood Prize for actually optimal scheduling of bridge deck rehabilitation and replacement. And even though it was many years ago, it seems like that problem still exists today, given the infrastructure in the United States and around the world. One of the things that, for me, that was a big highlight is mentorship. I was very fortunate to when I joined the Sabre research organization, we first started the research group at Sabre. I got the opportunity to work with 3 people specifically, Barry Smith, Alice Johnson, and Tom Magnanti. And what that helped me do is get a really good, solid grounding in some of the things that basically shaped the airline industry today. We started off in those early years actually developing the very first revenue management systems. How do we determine what price to sell every airline seat at? And how does that change over time? And so we took that into all sorts of different directions. And the research organization had an internship practice for academicians to join us and work with us. And that's where Ellis Johnson and Tom Magnanti came in. Ellis was from Georgia Tech and Tom was at MIT. And together with those groups, we developed all sorts of things. And I was primarily involved with the development of what is known today as the fleet assignment model, how fleeting is done at the airlines. And then also a thing called O&D revenue management. How do we actually manage the seat inventory in real time, which led to real-time revenue management as well as dynamic pricing. We've had a number of really good highlights that I'm very proud of for the team. And if you look at my organization has 4 verticals in it. One is air science and tech. Second one is surface research science, and that's the routing of the middle mile space. Then we have marketplace science, and then sort tech science, which marketplace science deals with how do we price loads and how do we manage dynamic ad hoc loads that come into the system or cancellations. And then sort tech science is actually managing the process of sorting packages so that we get them onto the right trucks and the right aircraft in the system. But to start off with AST, real early with the Air Science and Tech organization, we were able to develop a clean sheet scheduling optimizer that used the origin to destination package flows as an input and was able to actually optimize the schedule. Now, the other thing it did too is that our first usage of that, we were able to do that in the peak of 2017. We applied that. And we were able to reduce the number of aircraft that we needed to fly for our peak schedule during the holidays by 10 aircraft, which actually allowed us to eliminate all the charter aircraft that we needed for that year that we would have normally used.
Wow.
Yeah, that was a huge benefit. Well, then shortly thereafter, we applied it to the Europe schedule where we were starting to launch the air cargo service in Europe. And we were able to take their initial schedule and we could fly it actually and do better. So we could actually up the amount of volume that we could carry reliably. So that's how we actually launched Europe. It's actually put Europe in place.
That's some significant cost savings and just the need to procure those resources. That's a tremendous win for operations research, I'd say.
Yeah, that's true. And some of these problems are huge, right? I mean, the air problem for North America alone today actually consists of about 4.5 million fleet flight combinations within the schedule. And we have to whittle that down to be able to fly that with the 100 or so airplanes that we have and have it repeat day in and day out and do it reliably. Yeah. Also in that area, we've got some things where we've actually built some of the best real-time tracking and managing systems for the network, where we can actually watch the network minute by minute, dispatching the aircraft landing, unloading, so forth, and monitor what's going on and make corrective actions if needed as we go through the day. As part of the air network, the expansion that we've had last fall, we actually launched the KCVG or the Cincinnati Air Hub. And the Air Hub is very special because the team actually coordinated all the tech associated with that launch and that building, as well as made fundamental changes to our underlying tech network to use what we call ICAO code standards across the airline industry that identifies each node in the network. And that was a big change, but we did that. So if I move out of the air science and tech and let's jump into, let's say, marketplace science. And the marketplace science, a couple of big opportunities that we actually grabbed onto and were able to work on. Some years ago, when we first started, one of the scientists who just joined our team, when we were relatively small, and we came up with an idea to broker last minute loads dynamically using a combination of optimization and machine learning. And so we could price these loads And we call that the relay load board. And it uses a dynamic pricing optimization that is driven by machine learning combined with traditional optimization to come up with prices for the last minute load. Typically in this industry, in the ground transportation, in the trucking industry, you have load boards and you submit a bid that you can haul a load from A to B at a certain price. Well, instead of doing that, what we did is said, no, why don't we just offer a price and everybody can look at it at the same time. And if they want it, it's theirs. The first person to click on it, it becomes theirs. That actually changes the way this industry works altogether. And we put that together, started out with a real small pilot. It got accepted very quickly. And today it actually saves us hundreds of millions of dollars. But the other thing it does, it allows carriers, big and small, to participate in hauling loads for Amazon. If you're looking at just bidding side, doing only bidding, it usually ends up being the large carriers that can actually afford, put bids in and so forth. The smaller carriers don't get that opportunity. And now this actually allows all of them to actually participate, which is a good thing. Along the same lines is our relay load board actually deals with these short-term loads, right? The things that happened in the last 6, 12, 24 hours. But prior to that, we've developed another set of pricing algorithms that go into what we call the relay carrier marketplace. And we call it RCM, and we use some dynamic pricing there as well to actually establish short-term and long-term, medium-term contracts for carriers. And then I guess one other area to actually talk about is on the surface, what we call surface research science. We actually look at how does the Amazon transportation services, how do we actually optimize all the loads that we have running across the country or into Canada or even in Europe? How do we optimize the routings of those loads? Our network, what we call the middle mile transportation network, contains about 10 to the 88th possible routes today. Now, that's a big number, right? I mean, this is, if you think about the big number, there's a lot of zeros, yeah. But to put it in context, there are only 10 to the 85th atoms in the visible universe. So this is a big problem, right? Now, I'm not going to count dark matter or anything like that. So we'll skip that part. But that's a lot. And so today we've actually built some algorithms, invented and implemented a number of state-of-the-art algorithms that can actually solve that problem and optimize the routes for the trucks that we have in 4 hours. And at the same time, reduce our costs across the network. Our initial cost reductions were in the order of about 7% when we first started. Now, what we used to before we had these algorithms, before we'd actually developed it took 36 hours to do a very, very small fraction of that problem. So we've moved a long ways away from that. And today we're really out looking at how do we do this in real time now so that it can be very quick.
Wow. I mean, that's amazing when you think about it's almost like your career perfectly sets you up for this role. I mean, your mentors are giants in their field for sure. But I think the really cool part is that all of these new models and new approaches that the science people worked on are actually all the way in production. They're running systems, they're generating real results and having huge impacts for our customers. And it's great to see science coming off the research paper and actually into practice, making these decisions in this automated scaled fashion. That's just fascinating.
Yeah. It's a dynamic group. It really is. Yeah.
Yeah. And I mean, it's almost a tough question to ask, but I'm going to ask it anyway. So you've given us all these great, contributions. Is there any single thing or a subset that you're most proud of?
Yeah, I think it's, let me just, in concise terms, it's the team. They are bright, they're creative, and they're always up for a challenge. And that is what makes this work. Whether they are software development engineers or research scientists or product managers, they are all coordinating together and they're all dreaming about what we could do not what we've done in the past, but let's think about where we're going in the future. At Amazon, we have a lot of leadership principles, but this team that we've developed over the last 5-6 years really exemplify a couple that are really important, which is bias for action, invent and simplify, dive deep, deliver results, and most importantly, think big. Try to think of things that are not where we've been, but where we're going. So that's where we really want to do. So, doing the same thing over and over again isn't going to really do anything. But actually, let's look forward.
Yeah, that makes a lot of sense because, you could have the greatest ideas, but without the bias for action to actually get them implemented and try them out, they could be great theoretical ideas. But then to your point, I could have the most brilliant, theoretically complex formulation, but if I don't know how to invent and simplify it into something that we could actually code up, prototype, and test, we would again be left with just research that does not be able to be converted into practice. So that does make a lot of sense. And I like the fact that you mentioned it's not just the scientists, but we've got these key software development engineers that are also working with the scientists to make this research into reality. I think that's just fantastic.
Yeah, it's a good interaction between them because a software development engineer will say, well, look, that seems kind of complex. What if I did this? And you know what? We may end up with a better solution. But it's the result of that collaboration and coordination has really helped us put out some tools that are the envy of the industry, both in surface transportation as well as the air transportation area.
Absolutely. And with those software engineers also inventing and simplifying, to your point, it's like we're all reading from the same sheet of music here and if you will, rowing our boat or our plane in the same direction. Yeah. So that makes a lot of sense. So you've set a great, established the history of where we've come from, where we are today, some of your big wins for the team. So let's look even forward. Let's do what you're saying. Let's not focus on now, but where we're going. Where do you see this team going in the next 5 to 10 years?
Yeah, I see 3 primary things that we're going to be doing. I start off with automated operational decisions and decision modeling. I think that's going to be a very important one. The second one, I think, is going to be integration. And then supporting all of that, I think we're going to end up doing a lot of hybrid modeling. So if I walk through each of those, in the terms of automated operational decisions and automated decision modeling, what I mean by that is let's automate how the decisions are done. So if you have a huge network, it's really almost impossible for an individual to see a better solution by inspection. And it takes a lot of time to do that. So if we can automate these decisions, we can give them options that actually allow them to keep the network running and operating. It also helps them. We want tools that anticipate disruptions so we can act proactively to prevent delays in the network, whether it's a delay due to a snowstorm that is impacting roads, or if it is a delay that is shut down an airport and we can no longer run that part of the network. How do we do that? And then actually the development of a recovery plan. Once I'm disrupted, trying to get back on schedule is a big task. And so if we can automate that, that's very useful. The other part of it is, if you think about just go upstream from the operation of the network, go upstream to the design of the network. Today, the networks are so big, they influence each other so much that it doesn't give you a good solution to think about building a network in isolation. So building a network for the air system or the air cargo service and building a network for the ground transportation and doing those independently does not give you the right solution. So that's what I call siloed thinking, right? So let's get out of the siloed thinking. Let's start really thinking about how we integrate these systems. So there should be constant feedback loops. What is the operation telling us that we put into the design that didn't work? And are there options that I'm not considering? So if I have an airplane cancel due to a mechanical event, to a crew member calls in sick, can't be there, or is stuck somewhere in a snowstorm, or is delayed, or are there ground services that I could use instead? How do they interact? So that integration is going to be very, very important. to make sure that we continue to get packages to our customers on time as promised. So we need to scale this. This has to be able to do it. Now, how do you do those two things? How do you automate decisions? How do you integrate the design and then use those automated actions in the operation to feed those design decisions? Well, I think what you need to do is what I call hybrid modeling. And that is the use of things like reinforcement learning or machine learning approaches combined with traditional optimization, whether it's a mixed integer program or if it's a dynamic program or if it's a meta-heuristic, an iterated local search or using a subgradient algorithm or something like that. But actually not using the machine learning as a pre-processing step or post-processing step to an optimizer. Actually, let's build it into the optimization process and see if we can combine those. That's where I think we're going over the next 5 to 10 years.
Yeah, that makes a lot of sense. I mean, it's sort of one of my favorite phrases is if your only tool is a hammer, everything looks like a nail. And to your point about hybrid modeling, we cannot just bring one single tool to the problem and hope it'll force fit it. We have to have that broad suite of approaches in this hybrid modeling mindset that we can go after these big, nasty problems with. That makes a lot of sense. And so, if I think about your education, your career, the math, the science, the optimization, there are clearly technical skills, reasoning skills that, you have used to become successful. But as a former faculty member myself, I think we miss out on the opportunity to develop what I'll call soft skills or unexpected skills that, are there things that in reflecting back, you realize that you needed to make yourself successful that maybe you weren't just taught in the standard engineering curriculum? Does that question make sense?
Oh yeah, absolutely. Yeah. Yeah, I think there's 2 or 3 of these that are really important. I think most important right off the bat is I think you have to be open-minded. You have to be accepting of other people's ideas. And in my group, in the team that we have at Amazon, I encourage people to come forward with ideas. So if you're right out of school and you signed on to us as right out of school starting software development engineer or a starting research scientist, you have an idea and you're worried about talking about it and thinking about it, come and knock on my door. We'll set up 30 minutes or an hour and we'll walk through that idea and see what we can do with it. I'm completely open to that because it doesn't matter how smart you are or how much experience you have, you will never have a corner on the market of good ideas. Mm-hmm. Somebody will always have some little twist to an idea or a new concept or a new direction altogether that suddenly clicks with you that says, oh, wow, let's go try that. And that kind of leads into the other 2 things I'm going to mention too, which is the willingness to take on a challenge and accepting of risk. When you have a new idea, you don't know how that's going to pan out a priori. You just don't know. You can kind of make an assessment. You can kind of think about it, but you probably don't know until you actually do it. So take on the challenge and be willing to accept the risk. You're going to fail, at some point. Sometimes you will have failures, but you know what? You will learn more from those failures than you will ever learn from being successful in an approach.
Yeah.
Because if every approach just works out perfectly, you just kind of get in the habit of, geez, I know this is going to work, but in reality, if it doesn't work, if it fails, then you learn a lot. You get a lot of insight to those failures that help you in the future build an algorithm or build a concept that does work and works well. Does that make sense?
Absolutely. I mean, yeah, the idea of taking on those challenges and the risks and, learn, fail fast, learn again, rinse, repeat, we have to do that kind of iteration. And that sort of ties in to, there are a lot of transportation companies, a lot of folks who say they do research, but I think you've got a unique perspective here. So I'd like to dig a little deeper here. What is the role of research in a modern transportation company? I mean, you mentioned the airlines now, Amazon, there's lots of companies that have research with air quotes around it. But what do you see as that role?
Yeah, I think the role of research in a modern transportation company does go back to some of the things I mentioned earlier. But the thing to remember is transportation is a key component of the modern supply chain. If it's not there, people are not going to get product delivered. They're not going to get the raw materials they need to actually do the manufacturing either. Mm-hmm. So transportation is a key component to this entire network. And we're seeing that today with, the disruption due to COVID and other things like that. We're seeing that. But for that part, I think a couple of things I would actually stress is I've talked a little bit about automation. I've talked a little bit about integration. I think those are very important key components to this in the modern transportation industry. But what I would say is in terms of those, automation, again, we've talked a little bit about it. How do I make decisions in an automated fashion, relying on some of these ML and optimization techniques? And how do I make those decisions fast so that I can move forward? How do I integrate these systems so that I'm not making decisions in isolation, right? It's a classic case. There's a great case that everybody will understand from the airline industry, right? Is I have a scheduling department and I have a pricing and revenue management department, and they don't talk to each other. So scheduling department has an airplane on a certain leg, right? They're flying, let's say, Phoenix to Indianapolis. The plane goes out every single day, just packed full, right? It's always full. So what does the scheduling department do? Well, the scheduling department puts a bigger airplane on that flight. Revenue management and pricing is over here. They're not talking to the scheduling department. What do? Well, they do two things. They raise the prices. And the second thing they do is they tighten up the controls on the seat inventory, right? In isolation, both of those decisions make a lot of sense. But taken together, I've got a bigger airplane and I've stifled demand. So the plane goes out half full. So we need to integrate these decisions so that they're working together, right? And I think the other place, the one that's the most important place for research in today's modern transportation company is looking at new business models, new approaches. Research should not only explore new approaches to solving some of these most difficult and combinatoric scheduling problems, but also invent new ways of framing and running the business. And great example that I used earlier was the relay load board. Let's completely change the way we actually go out and find capacity for last minute loads. Mm-hmm. Let's not do it the way we've done it before. Again, looking in the rear view mirror is great if you're wanting to see where you've been, but we need to focus on where we're going. And I think that is one of the classic things that research can do in the modern transportation company.
Yeah, absolutely. It's like you flipped the whole paradigm, and without that research, we wouldn't know it was possible, and all the savings and the greatness that came from it is just amazing. And you talked about adding in big carriers with little carriers. That sort of ties into something that I'm very proud about Amazon is that we do a lot of work and education on diversity, equity, and inclusion, and I've learned a lot through my time here. I'm curious, as we start our meetings with these tips and suggestions and with training, is there an inclusion tip that you really enjoy sharing or that personally kind of speaks to you?
Yeah, I think I have two. One of them is a quote by Grace Hopper. So for those listeners who may not know or may not remember, Admiral Grace Hopper was the computer scientist that actually developed the language called COBOL early in the days of computer programming and so forth. But she had a quote that I thought was really, really kind of neat, which is the most damaging phrase in the language is, "It's always been done that way." And I think that is one of the things that I learned early on in the airline industry and my career that, hey, if we've done it this way over and over and over again, we're not going to get any better results. So when that phrase is used, we've always done it this way. That's a call to pick up and start thinking about how we could do it differently, in my opinion. The second one is one of my own where I really think is this goes back to being open to new ideas and so forth. And I say, the way I put it is, listen with the same effort and passion that you speak with. So if you're excited about a new idea and somebody else comes to you with a new idea, hey, take the time to sit and listen to what they're saying and encourage them to tell you where they're going and how they're doing it. Their idea may not work out in the end, but there may be some nugget of it that everybody can benefit from. So listening is very important. You will learn a lot by listening. And I think those are the two that I would call out as great inclusion tips, in my opinion.
Absolutely. It's those are wonderful because it's so easy to get excited when you're talking and you want people to be listening to you. Why not return the favor? And I think, your passion and excitement comes through in our dialogue today. And so I think that, what is it that brings that passion for you and to your role in the team and this organization that you've built? I mean, what keeps Tim Jacobs driving forward?
Let me pick on three. I think, number one, I would say, and these aren't in order of importance by any means. I think exploring new ideas and trying out new ideas. It's important to be curious, try to learn new things. But I think exploring keeps your mind active, and the discoveries that you make may not be applicable right now today, but they will certainly help you in the future, or they could. Another one I really like brainstorming possibilities, sitting down with the team or members of the team, or even members of my team and other teams getting together and collaborating on things and saying, look, what are the possibilities? How can we try to change this? What are options that we can say about it? This goes to what I call inventing the future. Don't let the future just happen, but invent it. And that's going a step farther than directing your future. That is taking control of where that business is going and how you're going to get there. And then I think one of the most important things to do with those two items in mind is watching your team grow professionally. There's nothing more rewarding than sitting and watching a new college graduate or a research, in computer science, an SDE, or an operations research graduate grow into a respected and recognized leader, both within the company and within the industry. So having them grow, that is what you're building, right? Inventing a bunch of tools, you have to remember, if a tool that you invent today, if you're doing everything that we've talked about today correctly, it will be obsolete at some point in the future. And it's these new graduates, they're going to take that tool to the next step, either by replacing it or enhancing it. And that is the capital that you're after, because that's what's going to make your team very successful.
Yeah, that makes a lot of sense. And I do have sort of a retrospective final question for you. I mean, this has been tremendous, such great depth and breadth according to what you do here at Amazon. So let's talk to the 18-year-old Tim Jacobs. Believe it or not, I don't know what he was like, but you've had this career experience. You've been on this journey and continue to be on your career journey. If you could write yourself a letter, send yourself an email, what would you like to tell your 18-year-old self?
That's a good question. Let me pick on three things again. I think first, be curious. Challenge yourself to continue to learn. There is always something else to learn. There's always something new to learn. My 18-year-old self was probably just starting to understand what a derivative was, in calculus, or maybe, and I can't remember exactly, but let's put it in that framework. But knowing, continuing to learn past that has been very, very rewarding. I think the other thing, another one is accept challenges. Don't shy away from a new challenge. Take risks. Be open-minded and try new things. And that's what I mean by accepting a challenge. If somebody comes to you and says, look, hey, you want to try to do this? This might be a good thing for you to actually go look at, or can you help us with this? Don't shy away from it. Take it on. See if you can do it. And so, you'll not always know the outcome a priori, right? You won't, but you will learn from that experience. So take a challenge and take the risk. I think the third one I think is really important is take care of yourself, both physically and mentally. I'm an avid distance runner. In fact, I love to run trails. I run trails on South Mountain and Phoenix and some other places. I really have done that all the way from high school forward. And I get some of my best ideas while running. Now, let me put my safety tip in here, and that is just be cautious, watch where you're going, and be careful not to trip, because I've done that too. And but you can generate some, thinking about having a clear mind and feeling that you're physically in good shape will really help.
Very cool. I really appreciate your time today. So after all of this discussion about, the cool things that's going on, I'm hoping that, you might have some openings on your team. And let's just say you do or you don't, but what are you looking for with people who might be coming to join Amazon's Air Science and Tech team?
Yeah, so we are looking for not just air science and tech, but we're looking across all what I call ATS science, right? Amazon Transportation Services Science, and then also AST, or Air Science and Tech. We're looking for a number of positions. We have openings in a number of every areas. First and foremost, we are looking for a number of software development engineers at all levels, really looking for people who have a good background in software development. And also including a lot of computer science majors today are coming out of school with a lot of ML experience and ML background, which is really good. We need that. Looking for research scientists at all levels as well. And those would be working on a whole bunch of different problems. Some of the problems we know today, but there are a bunch of problems that we will have tomorrow that we haven't really defined yet. And the third area is product managers and what we call TPMs, or technical project managers, to help us oversee and manage the direction of our products that we put out in terms of science modeling or actually applications and tools. And so listeners can connect with us online through LinkedIn or blogs and other things like that. So those are the type of areas that we're looking for. And we are growing. So we have some really neat things on the docket for 2022 and 2023 already. So get in touch with us. Let us know.
Yeah, absolutely amazing. I mean, when you talk about how the air cargo started from its, 2016, 2017 with, I think you said 3 planes to now over 100, just the growth and the scale. And that's only in one piece of this science monster. I just think that's tremendous. And definitely, Tim, I really appreciate you taking time with us today to kind of walk through your career, your org, what's going on. And thanks so much. This has been hugely entertaining.
Thank you, Scott. Thank you very much for having me. I really enjoyed it.